Awesome. Hi. Thank you. Sorry, lights. They're trying to tell me I'm good to go, and I can't see anything because of lights. How's everybody doing today? Good. Awesome. So we're going to talk about CSS, and we're specifically going to talk about how to work with animations and transitions in our CSS. A little bit of a content warning. I'm not going to flash or do anything like that, but there is going to be a lot of motion in the slide deck. So just if that's not your thing, I totally understand. But just so you know, there will be a lot of movement in the slides as we talk about animations, right? And all of those things. I'm Martine Dowden, and so the reason I came up with this talk is I realized when I was working with a lot of my UIs, I found that there was a lot of ways I could improve them and make them feel a lot more natural by adding even some minor transitions or some minor animations inside of the UI itself to make it feel a lot more natural. And that's when I got into, well, should I use a transition? Should I use this animation? Like, which one is best? Why would I use one versus the other? And so that's kind of what led me to come up with this talk. So the big question always is, if I'm going to put motion inside of my UI, which one should I choose? What's the benefit of a transition versus an animation? And will one even work versus the other? Because there's some limitations on either side. So we have, on one hand, we have a transition, which I can, go ahead and that I can use for things, especially when it's user-centered, where maybe in response to somebody clicking something. Or we have animations which can run multiple times, right? And that's going to use a keyframe where I can go ahead and add motion, and I can get those motions to be a lot more complex, right? Because at that point, I'm creating a keyframe. So let's dig a little bit more into transitions first, and then we'll go over some animation stuff. So why would I use a transition? Well, the first thing is a transition belongs and happens between states. So unlike an animation where you can define a keyframe, a transition is going to go between state A and state B. Those already need to be defined in our CSS in some way, whether it's because we're adding a class or removing one, whether it's because we're doing a hover state, or something like that. But those states already need to be defined, and the transition will happen between whichever properties we decide between the state A and state B. The thing about animations, it's only going to run once. When you add that class or you go ahead and hover or however you trigger that transition, it's going to only happen once. Once it's done, right? It's basically taking the styles that are being applied when that state changes and going ahead and transitioning those instead of making an abrupt change. And the last thing about transitions is that it generally requires some kind of trigger, whether that trigger is user done, such as hovering over something, or whether it's an automatic trigger in the sense of a response from something else. So for example, maybe it's a submit, they click something and some sort of motion happens, whatever the case might be, but there needs to be a solid trigger for that transition happening. So why would we use one? Well, the big main key for why we would use one are for response to something. So instead of going straight from this thing happened to this looks different, right? We can show the transition between A and B to our user, which will help them understand what is happening with our UI. So if we think back at the accordion, which we'll dig into a little bit of the code, a little bit that I was showing, that panel that opens and closes, right? If I can add a transition to that, I can show the users, they've clicked on the button, now they can see it open, they can see it close. It's not this instant, there's content, now there's not. And so that allows our users to better understand what our UI is doing. Because if we think of the real world, right? If I drop something on the floor, it's not instantly on the floor. There's a moment between state A in my hand, state B on the floor. Same with the door. It's not instantly open or closed. There's that transition piece. So if we think of the real world, we are used to seeing that from the time we're infants on up, right? That's a concept that we're very familiar with. Now we get into the web, And if these aren't implemented, we suddenly have these jarrings. We're in state A, we're in state B, and we no longer have that reference of what is happening to our UIs. So by adding those transitions between A and B, we help our users kind of connect to what the world they're used to, which is the being used to, you trigger something, you can see the development of it happening. We can get a much more natural feel, a much more organic feel, and we don't get that kind of uncanny valley that can sometimes happen with our UI, where things just kind of magically happen. So let's take let's look at a code example of how we might implement a hover, a transition on hover. So if I look at my first example and I hover over it, what I've done here, and generally this is a pretty obnoxious kind of hover state. I've made it really obnoxious for the purpose of a presentation because I knew it was going to be up on the slides behind me, and I wanted to make it real obvious. So more often than not, you're going to be doing a color change or maybe adding an underline or those sorts of things, right? They're not going to be this obnoxious. But the nice thing about it is if I don't have an animation, it's there and it's not. If I do add my transition, now we can see the progress between the two states. The thing about that is we often think of transitions as things that need to be very, very simple, right? We're going from state A to state B. Now, if you'll notice, I get smaller before I get bigger. And so the way we can establish that and the way we can really add complexity and some really cool things into our transitions is by messing with what function we use for our curve, for our Bezier curve. So over here, I have a custom Bezier curve. And so you're actually, even if you've never seen this term before, you're actually already using them in your transitions and animations today. Because the underline of these functions are what are pre-written in our CSS. We have some pre-written ones to help us so that we don't have to remember those fancy numbers, but they're already what you're using today. So our linear, it basically goes straight forward, right? There's no acceleration of any kind. Then we have our ease in and out, and ease out, which adds some acceleration into it. But all of it is based on that Bezier curve. Now, how does it actually function if we want to create a custom one so we can do more intricate things like, getting smaller before we get bigger, even though our transition is maybe from scale of 1 to scale of 1.5, I somehow managed to squeeze in a smaller scale in the middle, even though the transition doesn't define it. So how do we do that? Well, we look at when the underlying mathematics behind the Bezier curve is on 4 points. We have our 2 points over here at the bottom and at the top, which are define where the curve starts. And then we have these 2 handles over here, P1 and P2, that allow us to go ahead and control what that animation is going to look like. That's what allows us to control that curve. So in traditional math, we would end up having to define our P0, our P0, which is this point, P1, P2, and P1, P2, and P3. The thing with, with CSS is they've done a lot of things to define those for us to make that easier, right? Because all of us want to do high-level math when we're doing our UIs, right? That's what we all prefer and love to do, right? So what they've done for us, which is super awesome, is they've already defined our P1 and our P4. Those 2 points are defined for us, and all we need to do is define P1 and P2. So if we keep P1 and P2 between 0 and 1, we end up with a fairly standard curve, which is how we get those initials that were, or variations on those initials that are pre-baked into our CSS, which, by the way, there's absolutely nothing wrong with using those. I use them all the time. I don't have fun trying to customize it every single bloody time. But if we do want to make something fancy, that's where we go and play with it. So let's take an example. In this particular case, I've extended the curve so that it fits outside of that. So we see this last number. So we have, I start at, our x is 0, our y is 0.71. So these first 2 numbers define our P1. The second 2 numbers define the handle for our P2. And so see how this y number is much higher. This is how I can make this ball, if I animate its position, come underneath its original starting point. So by editing the curve itself, I can make it extend outside of the confounds that I've given to my transition. So that's how we get to those fancy transitions without having to resort to keyframes. Now, there's nothing wrong with doing a keyframe, but if we want to just have a standard transition, we can do a lot of things to make those a lot more interesting by editing the curve that we use in that timing function that we end up using. So if we go back to that accordion, which is one of the quintessential things we end up animating a lot in the when we look at our UI. So oftentimes we'll use a library, and it'll be done for us. But let's kind of dissect how that would be done and how we could custom code that and do it ourselves. Well, in this particular case, when it's closed, I've given it a height of 0. And when it's opened, I've gone ahead and tried to give it a height of auto, because I don't necessarily know how much content is in there. And so I want to see, okay, when it's opened, I want to collapse your height, and I'm going to go ahead and make sure that overflow is hidden, otherwise it's going to show, right? But then when I want it open, I don't necessarily know what the height is. And so if I go ahead and try to animate that, we'll notice that it doesn't work. It's just instantly opened and closed. And that is one of the limitations of transitions, is that you can't go from 0 to auto. And you can't go, and what we have to do is find ways around that. So there's a couple ways that we can fix that. And the first one is, in this case, I've given it a set height. I can give it a height of 300 pixels. So the only thing I've changed in my transition is I've gone from a height of 0 from a height to a set number. So that's one way in which you can use JavaScript to calculate how much size our content actually takes, and goes ahead and fixes that. And that goes ahead and opens and closes it. But that adds a decent bit of weight to our application, because now we have JavaScript handling some things that we may not want to have JavaScript happening. The other thing that we can use is do max height and kind of guesstimate. I know roughly I'm going to have this much content. It's not going to be bigger than that. But then your timing might be a little bit off, right? So we end up in situations where we can either use scale, we can use max height, or we can use JavaScript. There's 100 other ways, because just like most things in coding, there's about 7 ways till Sunday to go ahead and find how we implement something. But that is one thing that if you're trying to go to auto, it's not going to work. The other thing that we need to remember when doing transitions and animations, which is part of why I ended up making the little PSA about, there's going to be a lot of motion, is that not everybody loves having motion in their applications, and there's a number of things that can cause accessibility concerns with adding animations. So we definitely want to make sure we're using all of our semantic tags. With opening and closing, especially when you're hiding and showing content, you're going to want to make sure to have ARIA tags to explain to screen readers and assistive technologies what is being showed, what is being opened, and your states at that point. And you're going to want to make sure that if a user has motion, prefers reduced motion, which we'll talk about a little bit later, that is being respected. So animations and transitions don't necessarily change those general rules. We generally need to think of when we're doing accessibility. Those rules very much stay and are still very much alive as we code our animations. So with some of the rules we need to make sure we follow is that the animation, this is what I was talking about with reduced motion, right? So we actually have 2 media queries. Or one media query with 2 different values, sorry. One is prefers reduced motion, reduce, or no preference. So what that does is that looks at the device's preferences, because most devices will allow you to say, hey, don't put motion, don't put animations. And what that will do is it'll take those preferences that are already set by the user's device, and then you can put conditional code based on that. So there's kind of 2 ways you can approach it. You can either say, hey, if the user prefers reduced motion reduced, then we go ahead and cancel the animation in that case. Or we can go the other way around, where if there is no preference set, then we go ahead and add our animation code within that media query. We can go about it both ways, either way works. But this allows us to make sure that we're respecting our users' preferences, which are already going to be set on the device itself. So what about if instead of hiding and showing my content using height, what if I'm using display none? Well, the thing with display none and transitions is you can't really go from nothing to something or from something to nothing. So at that point is when we move over to using keyframes instead, and that's where we're going to have to use animations instead. So what's the difference between an animation and a transition? So our transitions went from already pre-made states, right? We went from changing either a height, or we can change a color, we can change our underline, we can change all sorts of things. Note about that, though, which I forgot to mention earlier, is that you're going to be transitioning things that are incremental. So a color, you're moving around the color wheel. A height, you're changing from 0 to whatever on that number. Things that are binary, so visibility hidden versus visibility visible, like that's binary, right? It's either visible or it's not. Those things won't transition, right? Because there's nothing to move from point A to point B. It either is or it isn't, so worth keeping in mind. So animations, they use keyframes. They run any number of times. We can set how many times we want animations to run, and they don't require any kind of trigger, right? They can just be set and exist on a class, and they go ahead and run as many times as we tell it to run, up to infinity, right? We can set infinite as our value and have them run forever. We would definitely, the places that we want to use our animations are when the motion between them are incredibly complex, right? So if we can do some tweaking like we saw with the Bezier curve, right? But if we're trying to do some really, really complex things, that's generally not going to be ideal. We're going to have to go ahead and move to keyframes. If we want the animation to be repeated more than once, right? If we want it to continue. Or if we're going from nothing to something or something to nothing. That's the kind of the three places that we're going to want to use animations. The keyframe structure is pretty simple. It's going to be it's an at rule. It's going to be at keyframes, and it's going to take at a minimum a to and a from. Right? We're going to go from something to something. So we're going from a particular set of styles to another set of styles. We can also do these in percentages, so from 0% to 100% and any increment in between. So you could have a slew of these for 1%, 2%, 3%, and you can skip some. So you can do 25%, 50%, 75%. But in between that 0 to 100, you can put as many percentages as you want. And so if you give it like a 1 minute animation, or an animation that takes 1 minute, which would be a really long animation. But like at 30 seconds, right, that's when you're going to hit that 50% mark and the motion in between. If you have an important in a keyframe, not that nobody's using importance, right? We know better, yes? But if you're going to try to stick one in a keyframe, it's not going to work. It's going to get ignored, just as a heads up. And so after that, just the same way as we define our transition, we can define our animation. We have a couple extra things we can define in our animation, which is obviously the iteration count, which is how much time we want the animation to, how many times we want it to go ahead and run. So let's look at that panel again, because that panel is kind of a, we can do scale to get it to open and close however we want. We can also use a kind of guesstimated height. I didn't want to inject too much JavaScript in this talk, so I didn't go down that road. We're going to go for scale again. I'm going to scale from 0 to 1, which goes ahead and hides it and opens it just fine, and I can animate that all day long, and I have an animation of 1. That works great. Let's go ahead and now look at how we would do that with the display none. Now with the display none, we have two states. We have our open one, which is absolutely, we're not displayed in our closed one where we're not displayed, and our open one where we're a display block, right? We're opening and closing. Pretty standard. The thing though, and then we're going to go ahead and have that trigger, which is that button, that on click, where we're going to animate our panel. So far, so good. We're also going to have on the body, we're going to have an on animation end. And so that's because when we open and close if we go back over here where we open and close our panels and we have our two states, when we run the animation, what's going to happen is if we try to close that panel, right, we're going to put that display none immediately, and our animation is never going to run because display none is going to remove the stuff from the DOM immediately, and we're not going to have the opportunity to run our animation. So we're going to have to wait for that animation to be over in order to be able to apply our display none. So this is where JavaScript comes into play, and we have a couple event listeners, one of which is on animation end, which will wait for that animation to be done, then trigger, and at that point we can go ahead and do whatever we need to do in order to remove it from the DOM. If we need that for transitions, it's very seldom. I've only used it once, I think, my entire career, but there is also an on-transition end. Also, in the same vein, we have on-animation start, if we wanted to run something for whatever reason when the animation starts, and we also have on-transition start. In this case, we're going to use on-animation end to go ahead and trigger removing stuff from our DOM. So we end up with basically 4 classes that we're going to play with, which is our open and closed states, and then we're going to have these kind of temporary classes that we're going to be adding in that are going to handle our animation as it opens and closes. Now, and which have our same keyframe. We're going to have our expansion keyframe, which opens and closes, and because we don't need to write it twice. The second time, we're simply going to reverse it. So I'm going from scale 0 to scale, completely open, which is great. And then on reverse, it's going to be taking my keyframes and just taking them backwards, right? So I don't need to write 2. I can just simply write, I can just have it run in reverse. So when we go ahead and animate our panel, what we're going to end up doing is we're going to find whether or not it's already expanded. And we're going to go ahead and, based on whether we have our expanded class on, which has that, whether we're display block or not, and go ahead and add our open and close, which at that point is going to trigger our animations. And when the animation ends, then we can go ahead and clean up after ourselves and then go ahead and add that display none or that display visible or that display block depending on the use case. The reason we need to clean up after ourselves is, one, we don't want to add the class open like 50 times. But the other thing is, remember how I said we can run animations any number of times? So if we say our animation to run once, right, because we only want it to expand once, we don't want it to play this 100 freaking times, right? That's not going to help anybody. If we just go ahead and re-add the class and the class is already there, CSS will be like, hey, I already ran that. I'm good. I don't need to run again. So that's why we need to make sure to remove those classes and add them back in when the animation triggers, because otherwise the animation will have already been considered as ran and won't run again. So let's look at our output, because that was a whole lot of JavaScript and CSS. So at this point, what we have is we go ahead and wait till when we click, it goes ahead and triggers the animation. We add that open class. It expands. When the animation is over, our animation end event triggers. It goes ahead and adds cleans up after itself. Then when we click it again, we do all of the things backwards. Does that make sense to everybody? Yes. I'm happy to take questions, by the way, because it's easier for me to answer them while the code is up than later afterwards when I have to go find the code. So don't hesitate. This works with what? Auto height? No, the auto height won't work either way. So you're going to have to, this is why I'm using scale in this particular case rather than, so the animation is based on scale and then I go ahead and do the display non-display block after that. But yeah, auto pretty much doesn't work in any use case. Some of the things that you can do is some of the frameworks, like have tie-ins to when things get loaded into and out of a component, where you can, instead of having to do the raw JavaScript, but yeah, auto height is still going to be a no-go, regardless of whether you're using animations or transitions. Good question, thank you. All right, accessibility, because of course we have to worry about that. It's basically the same thing as with transitions. Make sure we're using semantic tags as always. We're going to need some ARIA, and we're going to need to make sure we're following our users' preferences. So with that, worth noting, all of the code examples that are here, I've not put in any of the ARIA simply because I wanted to focus on the animation piece. So don't try to copy this in production. You'll need to make sure you add those accessibility in. I've simply tried to narrow down as little as possible so we could focus on what we were talking about today. So what about SVGs, right? Because one of the common use cases for animations are our loaders, right? We love to do our loaders for whether it's our applications, whether it's something's happening, whether it's something's buffering. We use those a decent bit, right? And so can we do our animations directly and in SVGs? And the answer is yes. As long as so you can either do it directly in the SVG itself, in which case you can just load the SVG file as a normal image. The other option is to go ahead and put your SVG inline inside of your HTML, in which case you can access it with your normal classes like anything else from the rest of your page. So in this particular case, this is the code for this guy, our little rectangles that are kind of buffering over here. So we have 5 rectangles that are just inside of our SVG, and we're going to want to animate those in order to handle making that loader. Now keep in mind, whether you're in SVGs or HTML, that auto height still doesn't work. Now the thing with SVGs though is you're going to have a height anyway, so because that's how SVGs work, right? We're on a grid, so that's going to kind of fix itself for you in that use case because you're going to end up with a height. Our CSS is pretty simple at the beginning. We have our loader. We have our rectangles, which each have a fill. Notice that some of the classes are a little bit different. As much as your fill ends up being background color, stroke, and you're going to use stroke instead of border. But anything related to animation, those are going to be the same as your HTML. It's just those handful of intricacies in terms of a lot of the styling might have slightly different key value property names, but all in all, it functions the same thing. It's the same way. It's just a different property name. So we're going to go ahead and create a keyframe. So at 0% or at the beginning, I want a normal scale. I want it scaled at 1. And about halfway through, I want it to be completely invisible. I want it to be at a scale of 0. And at the end, I want it to be back at a scale to 1. So we get that whole like boop, boop, and we're back and open again, right? And I'm using, and we'll talk a little bit more about timing in a second, but I'm using a fairly long animation because at this point, the more complex your animation is going to get, probably the longer it's going to need to take to run in order not to flash at people and end up being super jarring. And so that is what animates our rectangles. As you can see, fairly standard way of selecting my rectangles because I have it inline. I just call my loader, go ahead and select all of my rectangles, and I go ahead and animate them with my loader keyframe. And what we get is all of our squares animating top and bottom. And so now what we need to do is figure out how to stair-step them so they're not all animating at the same time, right? And so the way we do that is simply by using an animation delay. And so what that happens is the delay basically gives an extended time before the animation on that element starts the very first time it starts. So you can start stair-stepping when your animation starts in order to kind of trigger when things happen. So what you'll do, it's not a delay every time. So if you have a 3-second animation, it's not going to be my delay 3 seconds, my delay 3 seconds, my delay 3 seconds. It'll just be my delay 3 seconds, and then it runs as normal every 3 seconds. It loops. So for each of our squares, our first one doesn't have a delay, and then I start adding an incrementally more amount of time before the first square starts to load, and we'll see that that is how we end up with our stair step. So now that we've added our stair step, my first one starts, and then they each start, incrementally one by one, and then they go ahead and continue looping as normal. So I'll show that again, where we can see that the first one delays, and the first one starts immediately, and after that, it goes through the delay, and each can start in turn. So motion. We've already talked a little bit about the motion in terms of like making sure we are respecting our users' settings. The thing with auto motion is anything that lasts more than 3 seconds, we really need to start considering, is this a necessary motion? And so loaders are kind of ambiguous in that they're telling the user that you're not frozen, right? That something's happening, but they're not necessarily content. So that's when we need to start to make sure that, hey, maybe we have an alternate form of information. Maybe we have a percentage that's looping around if that's possible, or we give them maybe something that's less in your face in terms of animation, that's a lot more subdued if they have a reduced motion. But you still need to make sure if that animation is conveying information, you need to replace that information with something if you're not going to trigger it with reduced for users that prefer reduced motion. If it's something that has content in it, at that point we need to either find an alternative way of presenting that change, whether it's just no animation, you're just flipping from one thing to the other, or something that is a little bit more reduced and a little bit more subdued. The other thing we need to do is make sure that we're not flashing. And the reason is because flashing can cause seizures, and I think we can all agree that we don't want to cause seizures in our users. That's generally bad. And there's actually, they've calculated what the threshold is. They've done research, so we know flashes no more than 3 times in any 1 second. So if you've got something that's flashing, we don't want it to flash more than 3 times in a 1 second period. So you got to make sure that it's a slower flash rate than that, and then you'll be fine. So that's why, generally speaking, I tend to stay away from flashing so I don't have to worry about it. But if that's something that you need, blinking counts as flashing, by the way. Thankfully, we no longer have the blink tag to contend with, but it does count. So make sure that you're keeping under that threshold so that everybody can stay happy and healthy. One of the things you may have noticed in my code is that, and which I've kind of been very, very blatantly ignoring, is the fact that we have this transform origin that's popped up a couple times. And what transform origin does is it tells where we want that animation on the piece or transition, it works for both, to go ahead and start and end, and how that motion is going to be applied. But those work a little bit differently in HTML versus your SVGs. So let's go ahead and look. So if I do a top right, for example, and I gave a rotate to my div or to my square, that's where the origin is going to be. So that's where that rotation point is going to start. In an HTML, by default, it's in the middle of the element. So whether you're shrinking it, whether you're expanding it, or whether you're rotating it, whatever the case might be, the default origin is in the middle. In an SVG, it is the top left of the SVG itself, not the element you're manipulating, of the entire SVG itself. So that's where you can get some very interesting behavior, because the exact same rotation that was applied to this square has been applied to that square, except now we're rotating all the way who knows how. So that can be a little jarring, a little confusing if you're not aware that that's what's happening, but there's ways we can fix that. In HTML, obviously, if you want your animation or transition to start from somewhere else, that's no big deal. You're going to go ahead and give it, instead of instead of center, which is in this case, you can give it like top right, top left. You can give it percentages. It's going to take an X and a Y. And if you only give it one number, it's going to apply both to your vertical and your horizontal at the same time, like most properties in CSS that take an X and a Y. For your SVG, however, what we're going to end up doing is we're going to use the same transform origin, but we're also going to use transform box. And transform box is going to dictate where, not only is going to basically dictate where, like what pieces are you wanting to originate the transform origin from. So in this case, I'm going to tell it I want the transform box to be fill box, which goes ahead and targets the element itself. Just like in HTML, we can set, or in CSS for our HTML, we can set our box sizing to border box versus content box, etc. This is kind of similar, but for animations and SVGs. And so there's a couple other properties you can do. I think it's stroke box would be the equivalent of border box. So the property names are a little bit different, but it essentially works the same. So at this point, we're telling it, hey, I want it to be the actual element I'm targeting, and then I'm going to set the origin to somewhere else, top left. If I didn't have this second transform origin, if I just set transform box, then since the default for SVGs is the top left-hand corner, it would have been the top left-hand corner of our element. So it would have kept that default origin, just moved it from the SVG to the element itself, if that makes sense. Timing. So depending on your animation or your transition, there's kind of a rule of thumb. And so if it's a very small animation or transition, like so say I have an accordion and I'm rotating whether the little caret or the little arrow to show it's opened or closed, that's something very minute, that's something very small. Those kind of micro animations, generally you're going to want to keep those around 250 milliseconds. As the more complex your animation gets, the longer that animation is going to need to take in order for one, it to be visible, and two, for it not to be, very obviously jarring. Loaders are a completely different issue entirely because that depends on what your loader's doing, right? Like and how much there is to it and how complex of a thing it's going to do. And so that's a whole different timing gimmick. The thing is, and there's that between 250 milliseconds and 500 is kind of a general rule of thumb, but you're wanting to gauge it being slow enough to be visible, but not so slow that it looks like your application has lag. Because it's very easy to make that animation, make it seem like your application is laggy when it's doing, when there's absolutely no lag, it's doing exactly what you told it to do, but it'll give the impression that the application is sluggish or slow. So it's kind of and there's not a perfect, here's the equation to figure out if you're right and if your timing is on point, right? There's not, it's gonna take a little bit of give and take and a little bit of play and feel with it. So what did we cover? Because we covered a lot. So there's definitely some differences on when you want to use animations and transitions, right? Our transitions are mainly from state to state, and our animations are keyframes. Transitions only run once. Animation runs as many times as you tell it to. Our easing functions, like we can use the pre-built ones, they're awesome, but we can also use the cubic Bezier. By the way, on that, if you are wanting to play with those, there's a bunch of tools out there. If you write cubic Bezier builder or whatever, there's a bunch of tools out there on Google or whatever that are very visual, where you can start playing with the numbers and it'll show you what animation you're going to get out of it. That's usually how I calculate mine. I don't do the math. I just go ahead on one of those and have the tools help me do it because, why would I reinvent the wheel? There's definitely some limitations where we're going to have to use JavaScript to help us out, but we have events for that, right? We have on animation end, on animation start, same for transitions. We can do it in SVGs, no problem. By the way, those event handlers do work in SVGs as well, so if you needed that inside of an SVG, you can totally do that. And we definitely want to make sure that we're being responsible and making sure that our accessibility is on point, especially in terms of motion and not causing seizures, not making our audience seasick, and making sure we have all that ARIA written in for us so that we can tell our screen readers in assistive technologies what's going on with our code. And so with that, you can find these slides on my website. That's the QR code. I also have a course on Manning called Animations and Transitions that covers a lot of this as well. Feel free to check it out. And I hope you all had a wonderful time. I'm happy to take questions if you have any at this point. Nobody? Okay, well, thank you very much.